Hello, I'm Martin Kronberg, and this is the IoT Developer Show Season 4. In this episode, we introduce some HDDL solutions and talk about how they can be used to optimize a real-world computer vision pipeline. HDDL Vision Accelerator cards feature the same Movidius Myriad X technology that we saw in the Intel NeuroCompute Stick episodes. The HDDL cards have between 1 and 8 Movidius Myriad X chips in a range of form factors such as half-height, half-length PCIe, mini PCIe, and M.2. You can purchase an HDDL card from a variety of equipment makers, and you can get a full list of suppliers provided in the links. Depending on your use case, be it industrial, retail, agriculture, smart cities, or smart home, the video processing requirements vary considerably. For instance, the number of concurrent video streams, the video frame resolution, or the speed at which each frame needs to be processed. One thing remains constant across all these use cases. Apart from running computer vision workloads, the system has to perform other use case specific applications. This includes storing video streams, visualizing process streams, or making decisions based on the process streams, such as object tracking or notifying the user. Let's dig a little bit deeper into this workload balancing concept using a typical video analytics pipeline as an example. A video is fed into the pipeline from a camera or video file. This file needs to be decoded from an MP4 into a form used by the processing application, usually a byte array. Next, we will do some pre-processing on the image, scale, color correction, or rotation. This will help the analytics run more efficiently. After that, we run the image through our inference. This is where the image array is fed into a deep neural net model and produces a result: face detection, object tracking, or whatever our use case calls for. Next, we apply post-processing, so things like adding bounding boxes around detected objects or adding text to indicate identified objects. Finally, the image is encoded back into an MP4 or another video format to be saved and viewed. Now, this is a typical pipeline for a single image source. Often in the real world, like in a factory for example, there's a need for processing multiple video sources at the same time. With multiple cameras, you will have a bigger workload, and if you try to run everything in series, you will get bottlenecks in your pipeline. Decoding and pre-processing will take less time to finish than the inference of the image, and so you will end up with a queue of frames waiting to run through the neural net model. What we can do is run the workloads in parallel. For instance, have our CPU take care of multiple decode and pre-processing streams, and have one or more HDDL cards take care of the inference. By offloading the inference to multiple VPUs, we can avoid bottlenecks, by both running the inference more efficiently and freeing up processing capacity for the CPU. Another useful feature of running your workload in parallel is that as the number of video streams increases, you can scale up the number of VPUs to handle the additional streams. So, you can start with a Mustang V100 and then seamlessly migrate your application to a by 1, by 2, by 3, by 4, or by 8 cards. Now, you should have a better understanding about what a typical video analytics pipeline looks like, and an idea about how to use an HDDL card. Follow the links provided to the HDDL page on the Intel Developer Zone. In the next episode, we introduce you to FPGAs for AI-based vision inference applications. See you guys next time.
Hey, I hope you liked this video. If you haven't seen our other videos on the Intel Software YouTube channel, remember to subscribe, and don't forget to leave us a comment. Tell us what other material you'd like to see, and chat with other enthusiasts who watch our shows. See you next time.